My name is Gerhard. I'm a principal software engineer at Pivotal, where I've been working on RabbitMQ for a couple of years now, and I will be your today's host for the first ever TGI RabbitMQ episode. TGI RabbitMQ is a series of videos produced by the RabbitMQ team, which have been inspired by TGI Kubernetes. We can see here Joe Beda hosting the first ever TGI Kubernetes episode back in 2017, and today the history repeats itself in the form of RabbitMQ. Since 2017, there have been 100 TGI Kubernetes episodes. It is a very popular show. I'm a big fan. So because we have some catching up to do, let's get started. Today's topic is about upgrading RabbitMQ and how to upgrade RabbitMQ. We have Diego Lemos, which has opened an issue in the TGIR repository, which by the way is a public repository, and he's wondering how to upgrade RabbitMQ in production when there are tens or even hundreds of applications using it with minimal downtime. The thing which I appreciated the most about this issue is that Diego took the time to include a commit strip, which I found great, very fitting. And this is what I will be expecting from all future issues. If you want me to consider them, and if you want me to maybe cover the topic in a future episode, if there is a commit strip, it will be considered. Otherwise, it won't. So that's what I expect to happen. The timing for this topic couldn't be any better. And the reason why I say that is because the 3.7 RabbitMQ release series will reach end of life on the 31st of March 2020, which is just a couple of months away. Today, we will be upgrading RabbitMQ 3.7.23 to RabbitMQ 3.8.2. And the last thing which I want to point out before we get into it is that in this repository, you can not only find all the show notes, but you have everything you need here to follow along easily and quickly what we do in the episode. In the case of this episode, if you clone the repository and you run a couple of commands, you only need a Google Cloud account to do everything that I do, and maybe a budget of about $10. So that's what it takes to do everything that I'll be doing in today's episode. So what I have here is a copy of a clone. I cloned the TGIR repository. And if I go in season 1, episode 1, I can see all the files that go with this episode. The thing which I want to point out is the make file. And if I run make, I can see all the targets that exist in this make file. Now, make, even when it comes to make, I keep doing typos all the time. So I have make alias to m, and I wanted to point this out. And the first thing which we want to do is resolve all our dependencies. So in my case, because I already have Google Cloud installed, what it's asked me to do is to authenticate Google Cloud SDK with Google Cloud. So I sign in, I give it access, and I'm now authenticated. I now authenticated the Google Cloud SDK. What it means is that my project is CF RabbitMQ Core, yours will be different, and my compute zone is Europe West 2, which is London, so I can spin up all the resources that I need for this episode using Google Cloud. What I'm going to do now is spin up a RabbitMQ server, version 3.7.23 with management enabled in GCP. This should take about 10 seconds. It comes up really, really quickly. And then what I would like to do is open up CTOP on this VM. CTOP is a utility which will show us all the containers that are running on this VM, and will show us some statistics about them. The RabbitMQ container hasn't started yet. I expect it to happen shortly. There we go. There it is. And the next thing, the other container which starts, is the Stackdriver logging, which will centralize all logs in Stackdriver, which will be very handy to have. So now that we have CTOP, we can see RabbitMQ. Let's open up single view. Sorry, let me do that in a way that you can see. So it was enter. I just pressed O. I'm just used to these shortcuts. So we'll open it in single view. We can see the image, we can see CPU memory, and a bunch of other things. So now that we have RabbitMQ server CTOP, now we have CTOP running on this VM, let's take a look at the logs. Okay, let's do source env, make logs. This will open, as I said, the aggregated logs. We can see the boot steps. Okay, so RabbitMQ 3723, it has booted, it's there, everything is running. We can also see management is there. So let us open up management. Yes, of course, it will add a firewall rule. This is one of the nice things in that, oh, that was too quick. So let me just go back. This is one of the nice things of having a make target rather than having to, copy paste multiple commands or remember them. I can just nicely define dependencies. One target depends on the other targets. In this case, before management can be opened, there needs to be a firewall rule which allows access for my IP address, in this case to port TCP 15672, where RabbitMQ management is listening on. It opens it up in a browser. We can see it here. We can see the RabbitMQ node that we have just created. It's been up for 1 minute and 36 seconds. So the next thing which I want to do, we're down here, we'll be following along with these steps. The next thing which I want to do is simulate a workload on this node. And this is a workload which will make this node work hard. So we have a nice backlog. We have consumers doing their thing. I think we're going to wait a while longer until publishers start publishing again, and then trigger an upgrade, so that we trigger an upgrade in the middle of publishing, not just consuming. While we wait, let's take a look at workload CTOP, which is another command that we have here. So if I do workload CTOP, we can take a look at what the consumers are doing and the publishers, so the clients. So let's take a look at the single view. Okay, so as this is happening, we should see a nice spike when the publishers start working again. CPU, I expect something here, most likely CPU going up. Not so sure about network because we're using host network. And when that happens, we will trigger an upgrade on the RabbitMQ node. And we will run make server 38x. And this will stop the RabbitMQ app, which is a very important command. I'll cover it in 1 minute. And after the RabbitMQ app is stopped, it will take down the entire VM, this command, and it will create a new VM with a new RabbitMQ image on it. It's just an implementation detail into how this command works. So after this command completes, I would expect it to take maybe up to a minute. And the reason why it takes that long is because it has to close all the connections. And we have 8,000 of those. It has to stop all RabbitMQ plugins in a dependency-aware order. It has to stop the TCP listener so that no new connections can be established. Then it has to flush all the data to disk, and there's a lot of data in flight, right, from those publishers. So all the messages will have to be safely stored. And then it will have to stop the message store. It will have to stop the schema, which is Amnesia, the schema DB. And when all of those things are done, then the only thing left running is the Erlang VM. And the Erlang VM is actually the system process. So from a system supervisor perspective, nothing has changed. Everything is fine. The PID is there. The process is running and nothing needs restarting. But internally, Rabbit is no longer running. And that's a good thing because we got to a point where it's quick and very fast it's quick and easy, and it's very easy to cycle the system process. So if we didn't have to tear down the VM and create a new VM, which by the way is just how this compute instance update container it works behind the scenes. I mean, really, we would only have to stop the container, start a new container, reattach the disk. There's a persistent disk where all this data is stored, which would be much faster than taking the entire VM down, but so be it, that's okay. So in our case, we can see that the instance has been restarted. Let's go back here, and what we see, state is restarting. That's interesting. I'm not quite sure why that happened. So I think this is a good time to look at the logs to see what happened from a logs perspective. So let's open those up. Let's open up logs and see what happened. Okay, test stopped, detected rotation. So we may have more logs than we needed here. So let's keep going. This is basically the fluentd, so all the logs from when the VM is starting. And this is there we go. These are the perf test logs. So let's take a look. Connection reset, error during, that's okay. Connection reset by peer. But I do not expect the container to restart, because from the perf test perspective, yes, RabbitMQ went away, it came back. We didn't have the connection recovery interval. Maybe if I remove these, I may have, let me actually pin the logs. So let me pin, let's see what else, load older logs. Let's see, we will have too many of these and they aren't really helping. Yeah, that won't help. So let's pin, that's the pulling image, updating, no, here. Let's pin this one. Let's remove all of these filters and let's see if we can find what exactly happened here. Unfortunately, we don't see a lot more information. This is the startup when the VM got restarted, pulling the image. Progress, that's okay. Test stopped, could not connect to broker in 30 seconds. Okay, that's interesting. So even if it couldn't connect to broker in 30 seconds, I would expect it to keep retrying and not stop. But I believe that this is the connection recovery interval. So what we should have done, let's take a look. Let's open up our make file. Let's take a look at our workload. We had the connection recovery interval. There you go. This is the minimum limit, and this is the problem because the broker didn't come back. The RabbitMQ node didn't come back within 30 seconds, and because of that, perf test stopped. We didn't want that to happen, so we need to give it a bit more time. We need to let it retry for longer rather than giving up after 30 seconds, because in this case, stopping a VM, starting a VM, it sometimes can take longer. So let us save that again. Let us delete the workload. So I think this is the tab where we had the workload open. So workload stop. Yes, this will, again, stop will delete the VM. I'm going to recreate this. So I think what we want to do is redo our upgrade. And the reason why we want to redo our upgrade is because we do not expect the clients to stop working. So we want to have a configuration which waits for the RabbitMQ node long enough. In this case, it's 2 minutes. So we will wait for the RabbitMQ node up to 2 minutes to come back. And we want both the publishers and the consumers to continue exactly where they left off. So in this current context, oh yes, okay, so we upgraded our node. So let's go back here and let's open up management again. The IP will have changed, and that's okay. So we want to be using the new IP. There we go. So we can see that the messages got loaded back from disk. We can see this very high spike here, which will correspond to the disk reads. That's what that is. And the queues are back there, but obviously there are like no connections and no channels, so no consumers. Okay, again, we're waiting quite a bit for this VM to go away. I believe that sometimes, and this is my personal assumption, sometimes it takes longer to stop these VMs because you're paying by the second, right? And the longer a VM keeps running, right, the more you pay. So it feels almost as if the VM is kept around longer than it needs to be, just so that, you know, it can be built for, I don't know, up to a minute, maybe 2 minutes longer. Now our VM was running, burning a lot of CPU, using a lot of using a lot of network. So maybe it's just kept around to cover the costs. Maybe it's just an assumption. It would make sense, but to be honest, it shouldn't take 2 minutes for a VM to be stopped. Anyways, before we started, what I would like to do is, I know that we only just took this node to 3.8, but I would like to take this node back to 3.7. And this is something really cool, which is, while we wait for this, let me actually cover that very quickly. So 3.8 has a feature flag subsystem, and this is RabbitMQ 3.8. And what it means is that when a new RabbitMQ 3.8 node starts, to begin with, it is actually a 3.7 node. So it behaves like a 3.7 node. It's compatible with any 3.7 node, and certain features which are 3.8 only have not been enabled. And that is possible via a new system, via the feature flags subsystem. We'll cover it a bit later. And that's why in this case, because my 3.8 node isn't fully 3.8, so I haven't enabled 3.8 features, I can take it back very quickly to 3.7. None of the persistent data makes a difference, so there is nothing in the persistent data which has been upgraded to 3.8, if that makes sense. So I can take it back to 3.7, it will load the same data, and it will continue behaving as a 3.7 node. So again, we are paying the penalty of stopping the VM and starting the VM, because the container shouldn't take that long. Okay, so this means that RabbitMQ management haven't started yet, so let's just keep mashing maybe let's take a different approach. So logs lifecycle, let's see when RabbitMQ finishes starting. Load. RabbitMQ 3.7.22 server startup complete, so just now, good. So if I reload this now, it's going to work. There we go, and I'm back in again. We're back to RabbitMQ 3.7.23. So we're back where we started. We didn't do a lot of progress, but the reason why we're doing this is so that we can restart the workload, which, by the way, let me do that now. So restart the workload with a higher, where was it? Here. With a higher connection recovery interval. So we are giving it up to 4 minutes for the RabbitMQ node to be away. And the reason why we do this is because we do not want perf test to stop. The publishers and the consumers, as soon as RabbitMQ is back, they should continue exactly where they left off. So any of the messages which they wanted to publish, or any messages which they're consuming, they should just continue where they left off before the node got upgraded. So there we go. We have the perf test instance here. And I think at this point, there we go, all the connections are being opened. So we'll need to wait for these to get to 8,000. In the meantime, let me close some of these tabs because we don't need them. So we are back here. We are back at RabbitMQ 3.7.23. And as soon as the producers and the consumers are back, I'll trigger an upgrade. So let me have that prepared so it's nice and quick. Server 3.8x. There it is. Almost there. Let's give it another minute. we are just about here. Okay, there we go. So we have messages coming in. We will have very soon consumers starting to consume, and I want to see that before I trigger this. There we go. Consumers, let's just give it maybe another 5 seconds for the publishers to start publishing. Okay, perfect. So messages are on act. Good. That means that they have been delivered to the consumers. Consumers are consuming them. Publishers are doing their thing. Perfect. So now let's trigger this. Again, stop app. And yeah, this will go down straight away. Management will go down straight away. And this one is something that we want to keep an eye on. We do not want this container to go away. We can see the memory is going up. That's an interesting observation. The reason why the memory is going up is because all those messages, right, that wanted to be sent, now they can no longer be sent. So they are getting buffered and they end up in memory. Okay, so now the VM is being stopped. Cool. So RabbitMQ has stopped the application. Now the VM is being stopped. And I'm wondering if we can see anything interesting in the logs. Let's view like a live tail. Let's tail the logs. Successfully stopped RabbitMQ and its dependencies. Cool. There's nothing else new. So this was 10:35, minute 35. I'm wondering how long it will take to start this time. So what's the state of the VM? Okay, that has already started. That's good. So VM has stopped. A new one came back up. Let's see how long before we start starting RabbitMQ. I reckon it's going to be about 2 minutes. Let's see. And more importantly, is this still running? Yes, it is. Perfect. This is still running. Successfully stopped RabbitMQ and its dependencies. Okay. So here where we had CTOP, let's reset this. And let's do server CTOP so that we open up a CTOP on RabbitMQ 3.8. There we go. So it's already up. RabbitMQ is up. Server startup complete. Okay, cool. So RabbitMQ, let's take a look at that. So this was, that's more like what I was expecting. It took 1 minute and 22 seconds between RabbitMQ stopping and between RabbitMQ being fully stopped and the new RabbitMQ starting. And this included the recreation of the VM, which was the bulk of the time. I'm wondering, when did we start stopping it? So starting, startup complete, okay, here. So I think, there we go. This is a great one that will show us that me successfully stopped. So when we triggered stop app starting, did I miss it? No, I wanted to pin it. Can I do multiple pins? I thought I could do that. No, apparently I can't. Okay, that's okay. So started, server startup stopping. Okay, I wanted to see the time that it took between initiating the stop app and RabbitMQ actually stopping, and that will show us how long it took to go through the entire stop RabbitMQ phase. So 34:55, and it got to 45. That was 30 seconds, roughly. 30, actually less than that. It was 5 seconds there. We had 5 seconds there. Now this was 17 seconds. Nice, 17 seconds to successfully stop RabbitMQ from the moment we initiated stop app. And then we had this long before, yeah, the new VM was created and RabbitMQ started. And this is when the startup was complete. So it started, oh yes, that's another thing, of course. It had to run through all the boot steps, do the entire recovery. So that's like another interesting one. Between 36, 34, it took about 8 seconds for RabbitMQ to recover all the data from disk. That's not bad. So in 8 seconds, it was back. That's pretty nice from the moment that the container started. We've seen how long it took to upgrade. We confirmed that none of the clients crashed. Perf test is still here. It's still running, the producers, the consumers, everything is fine. We checked the management. So we did see that we got the new RabbitMQ 3.2. We loaded the messages from disk. Everything is exactly as expected. And in terms of downtime, we only had maybe 2 minutes and a bit, between 2 and 2.5 minutes, which is not bad. So that is how long it took this node from running at, I would say, almost full speed to, was like 600% CPU, network, disk, everything was utilized, to gracefully stopping and coming back as 3.2. So now that we are done with single node, we've seen that there will be some service unavailability. We won't lose any messages. The publishers and consumers, they will be aware. When RabbitMQ goes away, they will try to reconnect, and we know how to do that. We've seen how to do that. So now let's move let's do the same thing for a cluster. So what I will do, first of all, let me do workload stop. And this will stop our publishers, stop our consumers. And we basically want to recreate everything. And I'll do the same thing here. So let's do server stop. I don't have my autocomplete. No, that's not what I wanted. I wanted to do server stop. And I think I don't have server stop. Yeah, server delete. I was trying to do the wrong command. Yeah, server delete. So I want to delete perf test, delete RabbitMQ, and start again with a cluster. So workload stop. Yes, we're just running that. Server delete. That's running here. That only took 29 seconds. Not bad. We are running here server delete. That's not bad at all. And then we want to run server again to bring a new one up. Now we are going to recreate the first node. And we are also going to create 2 other nodes, which we will cluster. So do env make server RabbitMQ node 2 and RabbitMQ node 3 here. So we'll have 3 instances. We'll create a 3-node cluster. If I run instances, you'll see that RabbitMQ1, RabbitMQ2, RabbitMQ3, they're not aware of one another. So up here, we go to management. That hasn't started yet. So if I do server ctop, let's wait for RabbitMQ to finish booting. And it just did. So when I come back here, I would expect RabbitMQ management to become available shortly, and there it is, just booted. So now what I'm going to do, I'm going to use a new command which I have not used before. Actually, let me do it here. So let me do RabbitMQ server bash, and I will jump onto node 2. This is just basically opening a shell in the context of the RabbitMQ2 container. So it SSHs into the VM, and then it opens a shell docker exec in the context of the container. So now what I want to do, I want to RabbitMQ stop app. I'm just going to reset this node. I'm going to make it a blank node, and I will make it join cluster. And I'm going to make it join this node. So the only difference between the 2 nodes is a digit. So it's not 1, it's just going to join RabbitMQ1. And now if I do RabbitMQ, see if I come back in management, we'll see that RabbitMQ2 has joined this node. So they have formed a cluster, but the app is not running yet on RabbitMQ2. So let's start app. And when we do that, we will see this node boot, and now we have a 2-node cluster. So we will do the same thing for node 3. RabbitMQ stop app, RabbitMQ reset. If we don't reset the node, it will not join properly, because Neja, it will think, oh, hang on, I've already booted, so I already have like my view of the world. I never knew that I was part of the cluster, so I'm going to refuse to join the cluster. So the reset is important here. Join cluster. I think I still have it in my paste buffer. There it is. And it doesn't really matter. I can do 2 or 1. I'll just go for 2. Go cluster, and then the third one, because the second one is already clustered with the first one, is just going to join the same cluster. So RabbitMQ start app, and now we have a 3-node cluster. The reason why this worked is because all nodes are using the same airline cookie. If they did not use the same airline cookie, this would not be possible. And again, if they would not be able to communicate with one another, again, it would not be possible. All 3 nodes are clustered. Let's generate some workload. We'll start with the first one. And we will do the same thing 2 more times. Let's just do end, make workload, RabbitMQ node. Let's go for the second one, and let's do the same thing. RabbitMQ node equals 3. So while that starts, we will have 12,000 queues, 4,000 queues per node, and we will have 24,000 connections, 8,000 connections per node. So we'll have exactly what we had for 1 node, but times 3. And even though the different perf test instances are still connecting to only 1 node, we don't expect any of them to crash. They will all continue working. And even if, like, let's say 1 perf test instance would be connecting to multiple nodes, it would make no difference, in the sense that they will all behave the same. So while we wait for this to start, we can see queues being defined, connections channels being defined. I'm just thinking what else we may want to look at. Nothing really. We just need to wait for all of these to be created. And that will take some time. A couple more minutes we already have. So the first perf test instance, the first workload, is already off. That's the first one. We can see that file descriptors, socket descriptors 8001. So the first perf test has finished creating all the connections. The second one is on its way. And the third one has started as well just now. All queues have been defined. So we have 12,000 queues across the entire cluster, and we have connections being opened across the different nodes. So let's give them a couple more minutes for all of them to start and put some proper production traffic through all nodes. Let's, out of curiosity, let me, while we wait for that to happen, let me do server ctop on one. Let's see the first node and what RabbitMQ is doing on that node. So that's pretty busy. Let's do the same thing, server ctop on the second node. Node 2, and then we'll do the same thing. Node 3. So there we go. That's all our 3 nodes, nice and busy. Node number 1, node number 2. Maybe if we do single node, there we go. We can see the name. So 1, 2, and then node number 3. They're all nice and busy. And I think we should do the same for the workload ctop, just to make sure that they will all, actually I should have done this to begin with. Let's just do this, make workload ctop RabbitMQ node 2. Do the same thing here, make workload ctop RabbitMQ node 3. And then we can see the 3 different workload containers. There we go. So 1, 2, and 3, they're all applying pressure. They're all working nicely. We have, there we go, 24,000 connections. Everything is set up. So now we can start by performing a rolling upgrade. And we will start with the first node. So the first node we will take from 3.7. We'll do it here. So make RabbitMQ server 3.8x. Let's do the upgrade. Stop the app. And I think, yeah, because we're connected on the first node, RabbitMQ management stopped working. So let's fix that. Let's open a new tab and let's do management. But let's do this time, let's open management on node 2. So we'll be able to see what is happening. And this node is on the load. Because the first node is going away, it will take some time. There we go, it detected that. So we can see that from the queues that should be available, 9,530 queues are available. That number doesn't quite look right. I would expect 8,000 queues to be up and running. Why? Because this node is down, so any queue that has been running on that node should not be available. So I think these queues, some of them, there we go, we can see that they're down. We know that more are defined, but we can see here 12,000 queues, but they're down because, as we know, interesting, some queues are idle, some queues are running. Yeah, that's fine, okay, so that's fine. So coming back to, let's go back to the overview. This global count is slightly off, but otherwise we can still see consumers doing their work, and we'll also see publishers which are operating on the other 2 nodes. So as we do this, there we go, stopping instance, starting instance. So this is coming up. This is still running, so it hasn't gone down. This is the workload on node 1, and there we go, the node is up. And now we will refresh, and when we refresh, this node will advertise itself as 3.8.2 when it finishes. All the others are 3.7.23. Okay, this will take a while. We're just waiting for, there we go, we can see 12,000 queues, so that's now good again. And there we go, nice. So what we're seeing here is the first node did come back. The first node came back as 3.8.2, and the remaining 2 nodes are still 3.7.23. And the queues are back, so the queues are available. And what we will see here, as this is still running, the load will pick up when all the producers and the consumers will reconnect. They haven't attempted to connect to any of the other nodes. And that's, I think, something that we may want to simulate in that I don't know if they will have time now, maybe another time, we'll see. The point being that we may have tried to simulate what happens when a perf test will randomly try to connect to another node. That's actually an interesting one. You know what? Why don't we try that? It wouldn't be too difficult to do that. So let's modify very quickly where our perf test connects. So right here, container arc, the ERI is just one. It's just one ERI. So what I want here, I would like to get this connected to all RabbitMQ nodes. So rather than when the perf test comes up connecting to a single node, let's do node 1. And they will randomly pick to which node to connect. Node 2, and then we'll do the same for node 3. So they will randomly pick which nodes to connect to. Where am I? I'm here. All right. So this is 1, that's 2, and that's 3. Perfect. So let's see, which one shall we take down? I think let's take all of them down. Let's just recreate them. So in here, we're still waiting. I think these have reconnected now. We can see like a spike in CPU. If we go back to confirm, we should see memory. Oh, they did go away. Socket descriptors, and I'm wondering why that happened. This one apparently did go away. I'm not quite sure why I created this. This has been around for a while, but we can definitely see how they are reconnecting. Oh no, actually no, that does make sense. That does make sense. So the container didn't crash. The container has been running for about 9 minutes now. So it has been around before we've recreated the node. But what happened is there were no connections on this node. And the reason why there were no connections on this node is because perftest was waiting for this node to become available again. And when this node became available again, everything reconnected to it. So all the connections were reestablished. And there has been no activity until obviously all the consumers and all the producers, specifically the producers, have reestablished connections. So now we can see that happening. Okay, so that's fine. Nothing weird happening there. That's all good. So what I would like to do now, I would like to recreate these. So I'll do workload stop, and I'll stop it on the first node. Yes, please do stop it, because I would like to recreate this with the different URIs. And the reason why we're going to use different URIs is so that the producers and the consumers will connect to all nodes. So they won't connect just like to a single node as it's happening now. They will spread connections across all nodes. So what we would expect to see in that scenario, we would expect the ones that are connected to running nodes to continue consuming, continue producing. And the ones which are connected to the node that is being upgraded, they will just stop and they will wait for the node to come back before they reconnect. So while I do that, I think I would like to continue with all of these so that I can quickly cycle them back. And I can get them back with the correct setting that we've just made. So let's see how long before they come back. I expect it to take a couple of minutes, and we have another command here which is make instances, and we can see that they're being stopped. So what I would like to do is let's just watch this. Let's watch these instances as they're being stopped. So we can see all three are stopping. Now obviously the workload it's not really coupled to a node, so I wouldn't need to do like RabbitMQ1, RabbitMQ2, RabbitMQ3, but that's okay. That's not something that we need to worry about. So still stopping. They haven't stopped. Let's see what's happening on the RabbitMQ side. Yeah, so you can see everything is disconnected. There's some messages in the queues waiting to be consumed, but nothing's being published, nothing's being consumed. Okay, and in this case, we have upgraded one node, 382, so we are running with one 382 node, and the other two are still 3723, which I think is pretty cool in that we do have, you know, for some time, we can do this. Obviously, we want to upgrade them as soon as possible, but they're fine. Like the node which is running 382 is pretending to be 382, while in actual fact, it's sorry, it is 382, but it's pretending to be 37, so that is compatible. And once we enable 3.8 features, then at that point, all other nodes will need to be 3.8 as well. Okay, so they took about 2 minutes to stop. And interesting, all of them seem to have taken about 2 minutes to stop. Coincidence? I don't know. So now let me send this command to all all of these, and let's do workload stop. So what I want to do is, let me go to the beginning of the line, and let me do just workload, and then this will start workloads at the same time on all 3 VMs. And as we've seen now, I'm using URIs, so as I explained, they will try to randomly connect to one of the nodes. Okay, so they're coming up, and we can see running, so all 3 are apparently running. And while we wait for that to happen, let's go back here and let's do workload ctop, so that we open up ctop on all 3 of them. This is something which I should have done before, rather than typing the same command 3 times, but that's okay. Okay, single view, so you can see all 3 workloads. Let's just wait for all connections to be established. And now we'll see a much more even spread across all 3 nodes. There we go, and they will all start at the same time. Okay, so let's give them a couple of minutes for all of them to establish connections. We're already at 10,000, so we're halfway there. And as soon as that happens, you can already prepare this. We'll go back here. So this is already running. So let's go ctop on this node, and this is a 382 node already. So let's confirm that. Yeah, this is already 382. And this is a 3723. So we will be cycling this one next. So RabbitMQ server 3dex. Okay, so that's already prepared. So as soon as all the connections have been established, and they have, we'll just give the publishers a little bit of time to start sending some messages. There we go. Consumers are running. Cool. Publishers are just starting now. We can see from a socket descriptors perspective, we can see that RabbitMQ2, which is the one that we're going to cycle now, has the most number of connections, only by 100 more, 150 more, so not that much more. This one has the least number of connections. This is like the middle one. Okay, so we have a nice amount of messages being published. All the consumers are running at full speed, so I think now is a good time to upgrade RabbitMQ2. Okay, so that is now cycling. We're stopping the app. I believe, yeah, we are connected on RabbitMQ2, so let's jump to management on RabbitMQ1 now, so you can see what's happening. Okay, virtual host experienced an error, maybe inaccessible. It's just going down. It's just going down. That's okay. There's no error. It's just simply going away. It will come back as 382. Okay, so yeah, stopping instance. It's still going. There we go. That's away. There was no error. It was just getting stopped. So that's fine. Okay, so what else is happening? What's happening with the rest of the nodes? The consumers are still running. Cool. Okay, so still these connections are there. So the 2 nodes are making progress. RabbitMQ unknown. What's happening with this one? Stopping. So it's still in the stopping phase. Okay, it hasn't stopped it yet. Okay. And the reason why we're doing this is so that the reason for rolling upgrade would be so that the availability of the RabbitMQ service as a whole is not impacted. So RabbitMQ is still running, it's just that not all nodes are available. In this case, because some queues are only exist on specific nodes, for the duration of the upgrade, those queues will not be available. And we can see here from 12,000 queues, only 7,000 apparently are available. We know that more than this are available, but this counter doesn't seem to be quite accurate, I have to say. Okay, so this node is coming back up. It's in the booting phase. The queues are coming back up. Cool, so this is now good. So now all of them are back up, and including the ones that were unavailable while this node was being upgraded. Not before long. There you go. This node is 382 as well. There are no connections on this node. I would expect new connections to start getting established not before long, but the connections, the clients and the producers on these two nodes are unaffected. So they continue as if nothing happened. They can still publish messages, they can consume messages, but obviously both the publishers and the consumers on this node, they're not able to make progress. So they're not able to make progress because the queues were unavailable for the duration of the upgrade, but now they are available again. So as soon as they reconnect, they will continue working as normal. So we'll give this a few more minutes for that to happen. I would like to go and confirm that none of these have crashed, and none of them crashed, so all of them have started at the same time and they're still running. Just that some have, as I said, producers and consumers that are waiting to reconnect. They have the connection retry interval, which I think we've set to 4 minutes. Okay, so this is we're still waiting for connections to be reestablished. We can see the uptime. This node has been up for about 2 minutes. So I'd expect within the next minute for connections to start getting established again. So the one difference between a rolling upgrade and a sudden upgrade is that service availability. So while the service is degraded, RabbitMQ is partially available. So some of the queues in this case will be available, but other queues will be temporarily unavailable a few minutes, as we can see here. When we do a sudden upgrade, oh yes, and in the case of a rolling upgrade, we take a longer period to take queues down and then bring them up again. So it won't be we are spreading out the disruption. In the case of a sudden upgrade, we stop everything, so nothing will be available for some minutes and then everything will be available again. So in this case, we can see that the connections start getting reestablished, but we are also seeing that the clients, when they try to reestablish connections, they again randomized which nodes they are connecting to. So now we can see that the third node has the majority of connections, has 11,000 connections, and this node has just about the same amount, but the node which we just upgraded has only 2,000 connections. So that may be a problem. We have a bit of an imbalance here, but let's carry on. Let's upgrade the third node, the last node. Everything is still running, nothing has crashed. So let's do RabbitMQ CTOP, and now let's cycle this node. This is the last one that we need to cycle. So server 3.x. Okay. Still stopping the application. Okay, single view. So we have 2 nodes. And the last one, which is being updated just now. Okay, so it took 33 seconds, by the way, and this is something that we've added recently to see how long it will take for RabbitMQ to stop. The RabbitMQ app So it took 33 seconds in this case for that to stop. Okay, all of these are still running. We can see that this node is stopping. So this is the one that's going away now. And there we go, node running. Okay, so terminated. Okay, so I would expect it now to, yeah, starting instance. Cool. Okay, and that finished starting, so let's go for CTOP. And there it is. There is our new RabbitMQ node. So let's take a look. It says 382 as well, so they're all 382 now. So all that we're doing now is just basically waiting for this node to finish booting. Obviously load all messages from disk, start all the queues, and then start accepting new connections. Meanwhile, we expect the clients to eventually reconnect. I'm very interested to see how the connections will be spread when they reconnect again. But I suspect that the first node will get most connections. The second node will be the second one with the most connections, and then again this last node. So yeah, let's see what happens. And we can see another interesting thing. Okay, this node is up. We can see that it's been 19 minutes since we started cycling these nodes. So within 20 minutes we were able to upgrade 3 production nodes with significant load. So it wasn't that bad, I think. 20 minutes to cycle all 3 nodes. I think that's good. Okay, so consumers, producers have still not connected to this last node. We know that it will take between 1 and 2 minutes for that to happen because of our connection interval. Connection recovery interval, if I remember the correct thing. And we are just about here, rolling upgrades, feature flags. Interesting. So while we wait for this to for the consumers to reconnect, let's take a look at, and by the way, I forgot to do something here. There we go. That's what I wanted. Okay, let's take a look at feature flags. So RabbitMQ feature flags. There's a good blog post that has been published not long ago. RabbitMQ feature flags, the RabbitMQ subsystem. In this case, it's a guide. Quick summary. Okay, let's take a look at this. List feature flags to enable the feature flag. And this describes, how everything works and how the compatibility guarantees, and So let's run this command on one of the nodes while we wait. Let's take this first node. So let's do RabbitMQ server bash and let's feature flags. And there we go. All flags have been disabled. So quorum queue, virtual host metadata, all of them. Quorum queues are, I think that's possibly the coolest feature of RabbitMQ 3.8. We definitely want those enabled. So to enable them, to enable specific flags, enable feature flag and then name. Also pretty table. I think I would like this. Let's run this and let's see that. Cool, disabled. Okay, now that I'm doing this, I just reminded myself that we can also enable feature flags from RabbitMQ management. So if I go admin, feature flags, that's the one that I was looking for. So we can just enable flags, quorum queues, that's the first one you want to enable. Okay, cool, we have that. Virtual host metadata, all of them. And this is I could do it from the command line. Most likely you'd want this automated when it comes to deploying, but for the purpose of this, I'm going to do it manually. Okay, so this node, 8.6, I've already enabled all feature flags. Which one is 8.6? Let's see, so 8.6 in this case is this one, RabbitMQ1. So the next one that I want to go to is this one. So I'll just copy paste that IP address because it's the simplest thing. Guest. Oh, nice. So what it means is that feature flags are enabled on all nodes. That's really cool. They must be cluster-wide. I wasn't expecting that. That's actually a nice feature. Yeah, so Jean-Sébastien, you were the one working on feature flags. I wasn't expecting it to work this good, but yeah, I'm surprised that it does. So apparently, enabling the feature flags once is sufficient, enables them on all nodes. I didn't have to jump to any other node. And from my perspective, this was the easiest thing to do. Okay, so we did the update. We did the rolling upgrade. All 3 nodes are running 382, and we can see that from the perspective of even this table, there's no nodes which have 3723, so they all got upgraded. We have enabled all the 3.8 features on the entire cluster. We use the admin, but we can also do it from the command line. And when it comes to the connections, all connections have been reestablished. We have a few more than I was expecting, so I don't think this is completely accurate. Channels, I don't think that's accurate either. We are missing a few. It's really difficult to prove that, I have to say. From this perspective, something does feel wrong. Again, we have too many consumers. I think what I would do to confirm this is possibly stop the workloads and then start them again to see what happens. I would need to do that anyways from this perspective because of this imbalance. So if this was a production system, what I would recommend is just cycling all the clients, right? Like go through all the clients, cycle them. I would assume that that's again like an automated thing, in that whatever deploys them, you can say, hey, just redeploy everything, whatever automation you have from that perspective. So that's what I would do. In my case, because I have like this make targets, it's really simple to get out of here, and I will do stop all of them. Yes, please, and then I'll restart all of them, and that will definitely show us if there is an issue with these counters, which I suspect there may be, or if there is something going on in perf test, in which case perf test isn't quite reconnecting every connection and every channel is not recreating them. Interesting. So, what do you think? Perf test or RabbitMQ? I think it may be perf test, I suspect, because when we stop things, as is the case here, the counters are reflecting. Everything is 0, right? Everything is 0 everywhere. So this does look right to me. So now let's just wait for the last one to stop. And then when the last one stops, we'll restart everything and see how that gets spread. Okay, and then the last thing, sudden upgrade. I think this video is pretty long as it is. I don't think, no, it's long. We're not going to cover that in this video. We did a single node, we did a rolling upgrade, we did feature flags. We covered enough, so I'm happy with this. The last thing which I want to do is just show how this works, make sure everything reconnects, have that like nice even number of connections and channels. So let's see what's going on there, stopping. So this is the last one, which is a bit, yeah, the lazy one. So come on, let's do it. I know you can. And yeah, RabbitMQs, we have 1,700,000 messages, 700,000 messages, so almost 2 million messages. There's something else. There's a couple of other things which I haven't shown you here. A couple of nice surprises. I think the one that I want to show you now is we have actually maybe we should do that next. Yeah, let's do that next. So we have a drain, and a drain. Was it a drain? Needed by drain. Okay, there must be an issue there. Let me just very quickly take a look at the make file. Okay, let's Control-C this. Let's take a look at the make file. Let's do look at drain. Okay, RabbitMQ drain. I believe what the issue is here is that that was renamed. There should be one further down. There you go. Yeah, I just missed that rename. Okay, so now if I run this again, let me go back. Train. Now if I run this again, what this train does, it again starts VMs, but rather than publishing any messages, it starts VMs. It puts perf test on, but rather than perf test publishing any messages, all it does is it consumes them. And we are using, we're not using any acknowledgements on the consumers. So what it means is that RabbitMQ will deliver messages very, very fast. It won't wait for any acknowledgements. It will just offload messages as quickly as possible, most likely overwhelm a consumer that, you know, can't consume, I don't know, like 100,000 messages per second or a crazy high number like that, but that's okay because we don't care about these messages at this point. So consume them as fast as possible. We don't depend on any external system. And when we do this, the thing which we care really is we want to see those 24,000 connections. We want to see how evenly they spread across the 3 nodes. And we can see a pretty even spread right now. So we're 12,000. Actually, yeah, it's just 12,000. It won't be 24,000 because we only have consumers. We don't have publishers. So we have a pretty nice and even spread, 4,000 connections. And we can see that RabbitMQ is publishing, is delivering, 43,000 messages per second across all 12,000, across all 12,000 consumers. So yeah, we can see a nice drop. We're almost, like the entire backlog is almost finished. Cool, and we're done. That was it. That's how quickly, we just consumed 1.7 million messages. Cool. The consumers are there. They're waiting for more messages. There are no more messages. There are no publishers. So that's it. Okay. Lastly, I'm going to clean up everything. So let's do drain stop, and that's just going to stop all VMs. I'm going to do the same thing here. Just basically stop all RabbitMQ servers, because otherwise we'll end up paying for this, and we don't want to do that. So make server stop, server delete. Okay, and then this one is RabbitMQ node 2, and this is RabbitMQ node 3. And once we do this, there we go. All 3 RabbitMQ servers will be deleted. This is deleting all 3 VMs where we have perf test running, the drain. And if I watch my instances, everything's being stopped, everything's being cleaned. So yeah, there won't be any, we won't be leaving anything behind. So the last thing which I would like to mention is that if you would like to propose a new topic, what you want to do is open a new issue. This is a public repository, RabbitMQ TGIR. And how about I propose a topic for one of the future episodes? Something which I would like to cover in a future episode is how to contribute to RabbitMQ. So how do I contribute to RabbitMQ? And where do I start? Which repositories do I need to clone? Typos. Which repositories do I need to clone? How do I run tests locally? How do I run tests locally? let's just put this as a bullet list. They're always nicer. What else here? How do I run tests locally? How do I submit PRs? Because there's a couple of repositories. How do I submit PRs? I think that's it. These three. So let's submit a new issue. There we go. And if you have a topic that you would like us to cover in a future episode, do the same. Let us know. Thank you very much for watching. I will see you next month, last Friday of the month, for a future topic, for a future episode. It may be this one, it may be something else. I don't know. We'll see what happens. But yeah, thank you. Bye.